Okay, today we are looking at how to find the quotient of radicals. All this is really going to involve is extending our definition of what simplest radical form is and talking about it when fractions are involved. So basically, the same rules as before apply. Okay, so you can't have any perfect squares left underneath your square root. The number that's under the square root can't be divisible by a perfect square. The other rule that we add now is you are not allowed to have radicals in denominators. That's really it. Okay, you can't divide by a radical. Okay, so what we're going to basically have to be doing is finding a simple way to get rid of radicals. And the whole idea of what we're going to use comes from this. If we take the square root of 3 times the square root of 3, quickly in your head figure out what that is after you do any kind of simplifying that you'd need to do. Hopefully you came up with that would be the square root of 9, which is 3. You know, you could do the same thing for anything. The square root of 5 times the square root of 5 is the square root of 25, or 5. So if you multiply a square root by itself, well, that's great. Then you can get rid of it. Okay, we're going to kind of use that, and we're also going to use another simple concept, and that's, well, you don't have to turn it into just any perfect square. You know, for example, if you had the square root of 32, you could multiply by the square root of 32, or you could just multiply this by the square root of 2 to turn it in the square root of 64, which is 8. Basically what we're going to do is try to multiply by something that will get rid of the radical in the denominator. So here's an example problem. The square root of 5 over the square root of 7. And what we can multiply the square root of 7 by to turn it into a perfect square is the square root of 7. If we do that in our denominator, we have to do that in our numerator as well. So you're multiplying by the square root of 7 in the numerator and denominator of your fraction. On top, we get the square root of 35, and in the denominator, we just get 7, square root of 49, which is 7. Now we need to try to simplify the square root of 35 if we can. We can't, so we're going to move on. We're done. That's it. It's that simple. 8 over the square root of 24 is a little bit different. Now the square root of 24 can actually be simplified. So you have a choice. You can simplify it first, or you can kind of wait and simplify it after. It's your choice, but I'm just going to go ahead and for this one I'm just going to multiply by the square root of 24 right off the bat. Okay, and that gets me 8 times the square root of 24 over 24. And again, I still have to simplify that square root of 24. So before I start simplifying 8 over 24, I'm going to simplify the square root of 24 first. That's 4 times 6 using perfect squares method. And this gives me 16 square root of 6 over 24. Now we can simplify the 16 over 24, and that's going to be still square root of 6 here, and 2/3, because they're both divisible by 8. And that's our final answer. Square root of 6 can't be broken down any further. We have no radicals in our denominator. Let's take a look at a different one. For C, we know that we can write the multiplication of two numbers under a square root as a single root or as a separate root. We can do the same thing for division. So this problem is really just the same as the square root of 75 over the square root of 8. For this one, I have the same choices that I had in the last one, except I'm going to choose to do it differently this time. I'm going to choose to simplify my denominator first. There's no real reason for that. I just want to show you that both ways can potentially work. It's just when each simplifying step is going to happen that's going to change a little bit. So I'm actually going to simplify both of these square roots first. The square root of 75 is 25 times 3, and 8 is 4 times 2. Then I can simplify each of those. I get 5 square root of 3 over 2 square root of 2. I'm still not simplified because I have a radical in my denominator, so multiply by root 2 over 2 to get rid of it. And I get 5 root 6 over, these two are going to multiply to become 2. 2 times 2 is 4. So really, I think even if you look at the problem above, it looks to be about the same length, same number of steps, really. So it doesn't really matter when you simplify, as long as you make sure it all happens at some point. Okay, for D, I'm going to let you try this one on your own, but I'm going to give you a little bit of guidance first. What you want to do is you want to simplify each of those individual fractions, probably simplify each of those as much as possible first, then get a common denominator and put them together just like you would with regular fractions. So why don't you pause, come back, and we can take a look at it. Alright, so I'm going to simplify each of these individual fractions first, mostly because I don't want to multiply by the square root of 50. 12 is 4 times 3. 50 is 25 and 2. 27 is 9 times 3. And 8 is 4 times 2. You're going to see me use perfect squares method a lot, but if you use a factor tree to simplify the roots, that's definitely fine too. So now I get 2 root 3 over 5 root 2 minus 3 root 3 over 2 root 2. Now I could rationalize each of those denominators. When I say rationalize, I mean get rid of the square root. But I'm not going to do that. I'm just going to get a common denominator now because I can actually kind of see what that common denominator is going to be. If I get the 5 and the 2 to turn into tens and leave the square root part alone, I'll have a common denominator. So I'm going to multiply the first one by 2 over 2 and the second one by 5 over 5. Now I get 4 root 3 over 10 root 2 minus 15 root 3 over 10 root 2. I have a common denominator, so I can subtract what's on top, and I am allowed to subtract those because they have the same number underneath the root. So I get negative 11 root 3 over 10 root 2. Still have to rationalize the denominator. Still have to get rid of that square root. Multiply by square root of 2 over 2. Now you may have done this in a completely different way, and that is definitely okay. But if you finished with negative 11 square root of 6 over 20, you're in fantastic shape. Okay, so there's lots of ways you could have attacked that one. You could have waited and gotten the common denominator after rationalizing. There's just so many things you could have done. But if you ended up in this place, great. If you didn't end up in this place, try going back and checking your work. But if you can't figure it out, ask that as a question to start class tomorrow morning. All right, that's it for this one.